In this episode of Scaling Postgres, we talk about index deduplication, fast hierarchy, more monitoring, and cloud native. I'm Preston Jameson, and this is Scaling Postgres, episode 117. All right. I hope you, your family, and coworkers continue to do well during these times we live in currently. Our first piece of content is deduplication in PostgreSQL version 13 B-tree indexes. And this is from cybertech-postgresql.com. And they're talking about an enhancement that's coming in version 13 where they're reducing duplication in B-tree indexes. So basically allowing the index not to have to track every single value if it exists as a duplicate. And with this, you get some pretty significant space savings. So they say it's similar to how a gen index works, in that if the index keys for different table rows are identical, a gen index will store it as a single index entry. Now that's not necessarily how this works, but they're using the same concept to not have to store every single identical value in the index to make storage more efficient. And they link to the commit here. And they say, quote, the big difference is between the gen and the B tree with deduplication is that the duplicate index entries can still occur in B tree indexes. And they even include in the bottom here where they're testing it out, they show the table, the index, and they inserted, looks like 20 million rows. And then they compared the size of the indexes. Now, if you look at the gen index, that's pretty small compared to the B tree index. In general, just like looking in version 12, 51 megabytes for the gen index, 400 megabytes for the B-tree index. But access is a little bit slower compared to the B-tree index, at least in this use case. But in version 13, the B index is 126 megabytes, so not as small as the gen index, because again, it still doesn't deduplicate everything. But there's a significant savings going from 408 megabytes down to 126 megabytes. So in this example, a 3 times savings in space, which is huge. So that means this index could fit in a smaller amount of memory, which may speed access to it. So it's another great enhancement. Now to get the benefits, you need to do something similar to how the index changes for version 12 were done, is that you need to reindex. So if you do, say, a reindex concurrently in your indexes, you should get space savings for those indexes once you upgrade to version 13. But if you're interested in learning more, definitely check out this blog post. The next post, also from cybertech-postgresql.com, is PostgreSQL, speeding up recursive queries and hierarchic data. So the focus of this is data that exists in a hierarchy, and a lot of times you can use the with recursive CDE to query it, but they have another option here to speed up these types of queries using something called L-tree, which is part of the contrib package. And he says, quote, L-tree implements a data type L-tree for representing labels of data stored in a hierarchical tree-like structure. So since this is an extension, you go ahead and install it. And he created a table and inserted some data into a table, linking a parent and child to one another. So for example, B is the child, A is the parent. And he built this hierarchy here. And then using L-tree, you can get a listing of the hierarchy. So for example, if you say select using L-tree, it represents each label separated by a dot. And you can append rows to the end of the hierarchy. But he says be careful if the column is null, because then you can append it, where if it's a blank, then you can. And in terms of the label, you have to use essentially letters, because special characters like a dot will result in an error. Now he made a materialized view to pre-calculate these values. So he used the with recursive to create them, and he's using the L-tree so that the table looks like this, and the path to it is shown in the L-tree column here. And then you can query this data, so query the hierarchy using where the statement contains, for example, this, and it pulls out all of that set of hierarchy. So as he says, this is looking for everybody in A, B, C, G. And then you can also use an index with this. Now he doesn't mention, but I believe he's using a gist index to be able to use this, I believe, contains operator, so that you can speed up access to it. So if you have a need for querying hierarchical data and you want to speed up access to it, maybe check out the L-tree extension to see if it can assist you with doing that. Next post is Essential PostgreSQL Monitoring Part 2 and Essential PostgreSQL Monitoring Part 3. So in a previous edition of Scaling Postgres, we covered the Part 1 that covered cluster level parameters for PostgreSQL. Part 2 covers database level one. So for example, it says one thing you want to monitor is connected clients. Well, it shows you exactly how to do that by just looking at the pgstat activity table, what query you would run. If you want to track the size of your database, this is the query you would use. How to track table bloat across all tables in index bloat. And they have some tools that you would need to do to pull that out. Monitoring long-running transactions, looking at deadlocks, and then looking at the oldest vacuum and oldest analyze and what tables you need to query to be able to see that. Part 3 covers table, index, and system level metrics to monitor. That includes the table size, table bloat, how many sequential scans are occurring, as well as for indexes, their size bloat, as well as their cache hit ratio. In terms of system level, it covers memory used, the load average, and then the free disk space. So these have been a great list of things to monitor for PostgreSQL, and definitely I suggest checking out these blog posts to keep them as a handy reference to see what else you should potentially be monitoring in your PostgreSQL installation. And again, these posts are from the pg-io blog. The next piece of content is Webinar, Cloud Native BDR and PostgreSQL Follow-Up. So this is a webinar that they produced at secondquadrant.com, and they're talking about their Cloud Native BDR and PostgreSQL. So Cloud Native basically means container enabled, I've come to understand. So it's basically using Kubernetes to manage PostgreSQL or their bidirectional replication product, BDR. And it goes over an interesting presentation where they're talking about a number of decades ago, we were running on essentially bare metal servers, and then we started running on virtualized environments for the last decade or so, and now we're kind of moving into the container realm. Now, I definitely understand it from an application perspective. In databases, I'm still not really running them on containers. Again, because some of the disadvantages that potentially exist with local disk access or fast disk access, which you definitely want with PostgreSQL. But again, that has been continuously improving, and they're talking about using their operator that they developed to run PostgreSQL in a Kubernetes cluster and have it working and performing well. Now, what I think is more of a game changer personally is their BDR product, because that is essentially a multi-master database. And there it makes a whole lot of sense running a workload like that on Kubernetes, because essentially one database is the same as another within the cluster. But again, with that product, you have to keep in mind you have to develop your application differently. You can't do certain things in that type of environment compared to normal PostgreSQL replication where there's always a primary. And they can do things like utilize sequences to produce IDs and things of that nature. But I found it a very interesting webinar that kind of looks towards where the future may lead. So if you're interested in checking that out, definitely check out this webinar. You just need to click the link here, submit some contact information, and then you get to view the webinar. The next post is Optimizing SQL, Simplifying Queries with Window Functions. And again, another post I like to read about is window functions. So this is a pretty basic post that talks about understanding window functions. So they set up an environment with an employees that have departments. They insert a bunch of data into it, and then they start querying it. The first way they said you can get an average salary of someone using subqueries, and then they compared it to using a window function to do it. And then they go through and describe all the different window functions that are available in terms of row number, rank, dense rank, lag, lead, first value, last value. And then they show a query with a number of these different window functions in it. One to get the row number by department, one to get the rank by department, one to get the dense rank by department. And then they start looking at lag and lead to give you more information about the salary amount, and following up with a running total. So if you're interested in learning more about window functions, definitely check out this blog post from higo.ca. The next post is removing PostgreSQL bottlenecks caused by high traffic. This is from Percona.com, and they're basically going over a list of things that you should check out and consider changing to get better performance out of your PostgreSQL installation. And they compare each of the items that they mention from a complexity standpoint and from a potential impact standpoint. So the first thing they mentioned is tuning your performance parameters. So this is the PostgreSQL parameters. The primary ones are the effective cache size, shared buffers, and the work mem. And they go over how you would potentially want to set those, and they have some estimates that are listed out here. So definitely the first thing to check out and do. The next, they talk about session connections and how to manage those. Basically, how many connections you're having, and once you start getting a lot of traffic, you're probably going to want to use a connection pooler like PG Bouncer. So they discuss that and the different pooling options that are available. Then they're talking about optimizing auto vacuum. Now, interesting, they say some of the parameters that you should be changing is the auto vacuum max workers, maintenance work memory, auto vacuum freeze max age. And whereas you could do this, I generally prefer to make, as a first step, making auto vacuum more aggressive, and most importantly, changing the vacuum cost limit or the auto vacuum cost limit so that more work gets done with the auto vacuum. Because the problem with adjusting this is that all the workers use that same vacuum cost limit. And if you just add more workers, less work gets done for each worker process. So the most important value to change, in my opinion, is the cost limit, because that allows each worker to do more work in a given unit of time. And then if you feel you need some more workers, go ahead and increase that, but know that if you do that, each worker is going to actually do less work because the governor on that is the cost limit. So in my opinion, the number one parameter to change is the cost limit. Then they talk about advanced auto vacuum, and it basically looks like delving into table-based parameters, which you can definitely do to have particular tables vacuum more often. Next, they cover bloat, and their solution for that is using the extension PG Repack. But you can also minimize bloat by auto vacuuming more often, or vacuuming more often, to make sure that dead tuples are cleaned out frequently. How to avoid data hotspots, basically optimizing your indexes, make sure you don't have indexes you don't need so you get potentially more heap-only tuple updates. If you have very large tables with a lot of rows, consider table partitioning, optimizing for parallel querying, and potentially using denormalization techniques. Another area they mentioned is competing application processes. Basically, if you're running your application processes on the database, consider separating out those workloads. So you have a dedicated database and a dedicated application server or servers. They talk about replication latency. And here they're referring to synchronous replication as having a bottleneck of sorts, because you have to have a commit happen on two different servers, potentially crossing a network domain. So running asynchronously gets you more performance. And as I say, last but not least, they talk about the server environment. So basically things you can do on the hardware itself in terms of adjusting RAM, CPU, drive systems, as well as potentially a disk partitioning. So if you're wanting to learn more about their perspective on performance areas you can adjust to help manage high traffic, definitely check out this blog post. The next post, PostgreSQL write-ahead logging, trade-offs, bounded versus archived versus replication slots. So this is talking about when you're setting up replication, how that wall gets to the replica essentially. So you can bound it by specifying a certain number of wall keep segments on the primary so that the replica has them available to pull them over to keep replication going. The second method is archiving them. So you archive them on the primary server and you ship them somewhere so that the replica has access to them so that they can be replayed. Now that's not streaming, that's essentially log shipping, but it is a valid, one option to do. And then lastly is replication slots. That's where the primary and the replica are actually interacting with one another, communicating. The primary is aware that this replica exists, and it's going to keep all of those wall files until it knows the replica has retrieved them, and then it knows it can delete them. Now they go over the different trade-offs. Basically, a bounded wall where you're using wall keep segments essentially the primary can go on forever and it's not going to run out of disk space or shut down because it ran out of disk space, but it's not aware of any of the replicas. Whereas if you're using replication slots, essentially it has to retain those walls. So if there's some problem with the replica, you could start running out of disk space on the primary because the replica is essentially not consuming them. So again, they go over some of the pros and cons of these, but essentially the wall keep segments allows your primary to move forward without any risk. The disadvantage is that your standbys or your replicas can fall behind, and you have to manage that. The replication slots, you can be assured that everything is going to keep up to date, but you potentially may run out of disk on the primary or be able to mitigate that. And then the archived wall is really for log shipping, not really streaming. So the author's perspective is use replication slots and very closely manage your disk space, monitor for it, have alerts set up for it, as well as archiving the wall. But again, it's up to you, and they go over the different pros and cons in this article from enterprisedb.com. So if you're interested, go ahead and check out this blog post. The next post is locks in PostgreSQL, 3 other locks. And this is from haber.com, and I believe it's from something that may have been posted back in 2015 on postgrespro.ru, so a Russian site. So if you're interested in learning more about other locks such as deadlocks, predicate locks, advisory locks, so if you're interested in learning more about this, definitely check out this post. The next piece of content is the PostgreSQL Person of the Week is Markus Winand. So if you're wanting to learn about Markus and his contributions to PostgreSQL, definitely check out this blog post. The next post is Spatial Constraints with PostGIS and PostgreSQL Part 2 and Part 3, both from Crunchy Data. So they're talking about, of course, database constraints in regards to PostGIS with PostgreSQL. So if you're interested in learning more about different types of constraints for PostGIS data, definitely check out these blog posts. That does it for this episode of Scaling Postgres. You can get links to all the content mentioned in the show notes. Be sure to head over to scalingpostgres.com where you can sign up to receive weekly notifications of each episode, or you could subscribe via YouTube or iTunes. Thanks.